Hi, this class is to talk about hypothesis test for difference in two population proportions. So what we're doing is we don't know if the two population proportions differ and we'll test them. We're going to use sample data, confidence levels, and a z-score to test this hypothesis. So let's first understand what the z statistic or the z statistic is in this case. The z-statistic is the difference between the two sample proportions. These two sample proportions are um, estimates for the population proportions, okay? So we compare the mean of two population proportions using the sample proportions. So this is the difference. Do they really differ? Are they the same? If they are the same, this difference is zero. The bigger the difference is, the big this difference. So we want to standardize this difference. This is what the z-score is doing. We're standardizing based on the standard deviation of the sample proportion. Okay. Remember, we have two conditions. These are the two conditions. I talked a lot about them in the previous video, so I'm going to skip that. Again, this is the test statistic, and that's similar to this one. The only difference is that this formula comes up in the next slide because this is the standard deviation. Can you see the sigma? Standard deviation of the population proportions. You see, this is the same formula I have there. Okay, so this is the standard error. And there's one thing that you have to pay attention to, that is the pooled estimator. You have to use this pooled estimator. So the piece you have here under the square root, you have to compute all this to get them, okay? That's what you have to do. And remember, the hypothesis test, we have left tail, right tail, and two tail. If the difference is just to be negative, then is a left tail. If the differences are positive, then is right tail. If the differences is only different than zero, then is a two tail. Remember that I move this proportion to the other side of the equation to be able to understand that P1 is smaller than P2. So when I read the statement of the problem, it's easy for me to start this way and move to this hypothesis here, okay? And for each one of them. So let's take a look at the steps I propose for you to solve the problems. These steps are very similar to the other steps I proposed. So the first approach is the critical value approach. Again, you have to first develop the null alternative hypothesis and then determine if it's a lower, upper, or two-tail case, specify the level of significance. If it is a lower tail, you use the level of significance as it is. If it is upper tail, you do 1 minus the level of significance, and if it is two tail, you do both. And then you find the z critical associated with this level of significance. Remember, is equal z inverse and then the probability in the steps to hypothesis test for two population means. That's the same procedure up to this point. Okay, so this is the reason I don't have anything extra. You can go back and watch the video to see how you get the z critical, but that's the same case for the difference between two population means when you know the population standard deviation. And then you collect the sample data. This comes given in the problem, and then you compute the test statistic. But pay attention to this. You need to compute the pooled estimator and the standard error. The pooled estimator is this part here. Then you get the answer and plug in this formula. And then after plugging in this formula, you can go back here and have the z, okay? So that's what I'm saying here. You need to compute the pooled estimator. And then finally, when you compute the z, you have the z critical that determines the region. Then after you get the z, you compare the two, okay? I'm gonna show you here one more time for you to see that, okay? So that's, let me wait for, okay, this is the distribution. So you're going to find a z critical. Let's say it's in the lower tail. Z critical is right here. If the z statistic stats is smaller than the z critical, which means it is in here, then reject the null hypothesis. Okay. If it is upper tail, you have the z critical here, and if the z stats is higher than the z critical, reject the null hypothesis. Okay, is in this upper side. So what we're doing is with the z critical establishing the region in which you reject the null hypothesis, and if it is two tail, you're gonna have two z criticals, and this is the critical regions. Okay, so this is what we are doing step number 6. The second approach is similar up to the step number 3, the level of significance. Until step number like 4, when you find the z statistic, the test statistic, when you need to compute the pooled estimator. So you find the z statistic, and now you have to find the probability related to this z statistic you found in this step number 4. And these are the formulas you use depending if it's lower tail, upper tail, or two tail case. And then you follow these steps, and then you find the probability, and then in the last step you compare the probability, the p-value, with the level of significance. And if the p-value is smaller than the level of significance, then you reject the null hypothesis. So I'm going to stop here, and I'm going to show you in the next video how to solve a problem using these concepts.